we talk about maintenance and ultimately replacement even, these are big decisions that water systems are going to be making or make based on this data. So how can they build trust in the predictions and the recommendations that we're offering?
Yeah, absolutely. Yeah, we thought about this a lot when building this product. We run these models through checks and experiments, all sorts of things, so that we can trust how they perform. And we also want water systems to be able to trust them as well. And, that the community can trust that these are really good methods to make decisions by. So Ryan talked earlier about some of these rules of thumbs. We also call them baseline models. So thinking about how these decisions are currently being made if you didn't have a BlueConduit model. So for example, let's look at the mains that broke previously and think about maintaining those. And we put that into a mathematical framework so that we can then rigorously compare how our models do compared to that rule of thumb. And so one of the ways we do these comparisons is often called a time shift study. And what this does basically trains the model up until a certain date, so say 2 years ago, not letting it see what happened in the last 2 years, and then ask it to predict what's going to happen in that 2 years. So it's predicting into its future, which is what it will do when it also, goes out into the field and goes into our future. And when we look at and describe our models, we really take a holistic approach. So we never look at just one metric. You really need to look at a whole bunch of metrics from every different angle to see how a model is performing. Or you might think a model is performing well and it actually isn't, or vice versa. So some of the things we look at are, out of the top 1% of mains that the model said were the most likely to break, how many of those broke? Another one is, out of all the mains that had their first break within those 2 years, so it's never broken before, how many of those did the model correctly predict? In a recent example, our models performed 75 times better than a weighted model when looking at new breaks.